Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 10, Section 4, Part 7. And today we're talking about energy profiles of chemical reactions and how to read energy diagrams. We've done a little bit of this in the past, and we're going to delve a little deeper into it. Alright, so I want you to make a simplified view of this. So on the y-axis, you're going to have energy, and the x is as time goes by. And then reactants are here. We go up a little bit and then come back down, and this is products. I would like you to label from the initial energy to the maximum energy and label that activation energy. And then from initial to final, that's the energy released. That is your change in enthalpy. Make sure to not go all the way up to the top, but just from the beginning and the end. Once you have that drawn, I want you to write a little bit more, please. So many reactions have energy barriers, which are external energy needed to start a chemical reaction. This is the activation energy. So activation energy is the energy needed for that reaction to occur. So you see, this reaction is exothermic. It will release energy, but it doesn't just happen. You have to have a little bump up of energy, maybe the spark to ignite methane gas or something like that. So please write that down. And please write this down. Many exothermic reactions need an initial input of energy to proceed. And some of them, most of them need some energy, not all. So if no external energy is needed to start the reaction is spontaneous. But many are this type where some external energy is needed, so the reaction is considered not spontaneous. So the difference between spontaneous and not spontaneous is one needs external energy and the other one does not. Okay, so let's look at some energy diagrams and what we can figure out for them. So please write this reaction. 2 moles of solid sodium react with 2 moles of liquid water to form 2 moles of aqueous sodium hydroxide and 1 mole of hydrogen gas. Given this is its energy diagram. Couple of things, I have questions for you. One is, what is the change in enthalpy of this reaction? Another question I have is, this reaction endothermic or exothermic? And another question I have is, this reaction spontaneous or not spontaneous? So please draw this reaction diagram in your notes. You can do a simplified view. So it should be energy here and time or progress of reaction here. And then it's going to start up about 0 and then go down to about -285. And then this is this reaction we just talked about. So take a moment and make that in your notebooks. Okay, let's take a look at another reaction. So please write this down. 1 mole of solid carbon reacts with 1 mole of oxygen gas to form 1 mole of carbon dioxide gas. So we're going to make this diagram in your notebook, a simplified view, where you have energy on the y-axis and time or progress of reaction on the x-axis. And it starts at about 0, goes up, maybe 250, and then comes down to -400. So a couple of questions on this. Well, I'll start first. Is this reaction exothermic or endothermic? Another question is this reaction spontaneous or not spontaneous? Another question I have is, what is the activation energy of this diagram? And a final question is, what is the change in enthalpy of this reaction? Right, we will discuss your answers in class. And something else we are going to discuss in class is your reading on page 318 and 319, I believe. Please write this down and then be ready to discuss it. What do chemical engineers do? What are some products chemical engineering has produced? What are the goals of green chemistry? For example, how has green chemistry made dry cleaning better for people and for the environment? And then talking about biodegradable plastics on page 319, please write these down and be ready to answer them. What is biodegradable polyethylene? And it also talks about chemical manufacturing on page 320. What is the LeBlanc versus the Solvay process for producing soda ash, Na2CO3, also known as sodium carbonate, or washing soda? It's sold in stores as washing soda, and it's also used in manufacturing processes. And finally, on page 321, the atom economy. The major goal of green chemistry is to reduce waste by having more efficient chemical processes. So what do these words atom economy mean? And finally, your Chapter 10 notes are finished. Whew! Good job, everybody. Bye.